Learn like a pro.
Welcome! Today, we're going to crack one of the most fundamental skills in all of chemistry, balancing equations. And you know what? We're going to do it by forgetting all the complex chemistry stuff for a minute and instead thinking like an accountant. Welcome to the atomic ledger.
Okay, let's just dive right in. What if I told you that every single chemical reaction is just a transaction, and our job is simply to make sure the books balance at the end? We're not tracking dollars and cents, though. We're tracking atoms. Let's completely reframe how we look at this problem.
Now, before we start balancing any books, we have to understand the single most important rule in this entire game. I'm not kidding, this is a law of the universe, and it is absolutely unbreakable.
And this is it, the law of conservation of atoms. All it means is that in any chemical reaction, atoms don't just poof, appear out of nowhere, and they don't vanish. They just rearrange. They swap partners, they build new things, but the pieces you start with have to be the same pieces you end with.
So this brings us to our first little puzzle. When you look at an unbalanced equation like this one, it's actually breaking that universal law. See that? We start with 2 oxygen atoms on the left, but we only have 1 on the right. It's like an oxygen atom just disappeared into thin air. Our ledger has a problem, and now we have to be the detectives who solve it.
So how do we solve this puzzle and balance our atomic ledger? Well, we've got a very specific set of tools, and it's so important to know which tool to use, and maybe even more important, which one you can never, ever touch.
And here are our 2 tools. On the left, you've got subscripts. Think of these as the molecular glue. That little 2 in O2 means 2 oxygen atoms are stuck together. If you change that number, you're not just changing the number, you're changing the entire substance. So rule 1, do not touch the subscripts, ever. On the right, we have coefficients. Now these are your levers. These are the big numbers you put out front, and they act like multipliers. They let you change the quantity of something without changing what it is. And that is exactly how we're going to balance our ledger.
Okay, enough talk. Let's actually put this into practice. We're going to tackle our first ledger and put those levers to work.
So, first step, we take inventory. We've got 1 magnesium and 2 oxygens on the left, but only 1 of each on the right. The books are definitely off. So, what do? We pull our first lever. We put a big 2 coefficient in front of the MgO. That gives us 2 magnesiums and, importantly, 2 oxygens on the right. Awesome! Our oxygen is balanced. But uh-oh, now our magnesium is off. No problem at all. We just hop back to the left side and put a 2 in front of the Mg. And just like that, the ledger is perfectly balanced. 2 of everything on both sides. See? It's a puzzle. Okay, so you've got the basics down. But what happens when the equations get, well, messy? Trying to count every single atom one by one can get confusing fast. Luckily, there's a really cool shortcut.
Just look at this thing. Yikes! All those different atoms, trying to count every single nitrogen and every single oxygen separately, it's a recipe for a headache, and it's super easy to make a mistake. This is where just counting one by one can start to fail us. We need a smarter way.
And here is that smarter way. We'll call it the polyatomic hack. It's simple. If you see a group of atoms, like that NO3, the nitrate ion, that shows up on both sides of the equation without breaking apart, you don't have to count every atom inside it. Instead, you just put a mental box around the whole group and treat it as one single item in your inventory.
And this is the magic of the hack in action. Look how much cleaner that ledger becomes. Instead of tracking nitrogens and oxygens, we're just counting the number of NO3 boxes. We've got 1 box on the left and 2 on the right. Bam! It immediately tells you what you need to do next. It takes that complicated mess and turns it into a simple balancing act.
So, let's bring this all home. We can actually boil everything we've just learned down into a universal 3-step plan that you can use on basically any chemical equation that gets thrown your way.
Here it is, your 3-step plan. Step 1, take inventory. Just list on everything you have on the left and on the right. Step 2, box the packages. This is our pro move, right? Scan for those polyatomic groups that stay together and just treat them as one thing. And finally, step 3, adjust the levers. Start putting those coefficients out front to multiply your quantities until the left side of your ledger perfectly matches the right. Inventory, box, adjust. That's the whole game.
You know, this skill is so much bigger than just passing a chemistry class. It's about learning the fundamental grammar of the universe. Balancing an equation is how we read the story of how matter works. You now have this incredibly powerful tool for understanding that language. So the only question left is, what will you discover with it?